So I want to introduce the topic of probability, and we'll see in class why this is related to calculus. In particular, this is going to be a nice way to start to look at series, which is going to be our next kind of major topic. So first of all, I want to introduce some terminology, some just kind of underlying definitions that we'll use throughout. First of all, if we talk about an experiment, this simply means a well-defined procedure. Common experiments we'll see are things like flipping a coin or rolling a six-sided die. Once I've defined an experiment, then I can talk about the sample space. So this would include the set of all possible outcomes of an experiment. So once the experiment is well defined, then you can think about what types of outcomes you would expect to see. If you list all of these outcomes, that gives you the sample space. And finally, any subset of a sample space is an event. So a collection of possible outcomes we can think of there. To make sure this is clear, I noted before that one possible experiment is rolling a six-sided die. If that's the case, then I can start to talk about the related sample space or the list of possible outcomes. Sometimes this is referred to as an outcome space as well. So when you roll a die, then the die will land with some face up, and we can look at the number that we see there, and that would be our outcome. So one way to list the possible outcomes would be to list the possible values we could see on that upward facing part. So this would be a way to list that set of all possible outcomes. Then we talked about the idea of an event. Now there are lots of different events I could define here because there are several different subsets I could collect. What I'd like to do, though, is to describe an event in words and then make sure we can write down what the subset would be. So often with events, we use capital letters, typically from the beginning of the alphabet. So if I said that A is the event that you roll an even number, then that would mean that A would be the subset of our sample space that contains 2, 3, and 4. Now, if I then want to talk about the probability that A occurs, you can think of that as the likelihood that we do in fact roll an even number. Well, notation-wise, we would say that we would use this kind of bold-faced P. I would put what I'm taking the probability of, or finding the probability for. And then what we want to think of here is we say that we're in a situation where the outcomes are equally likely to occur. So there's no reason to believe that it's more common for me to roll, say, a 1 than a 6. So this event contains 3 out of our total 6 possible outcomes. And so we get that the probability is 3/6 or 1/2. Another possible event, let's call it event B, is that the event that you roll a number strictly less than 5. Again, that description allows me to find which outcomes I can include from my sample space. Here we would include the numbers 1, 2, 3, and 4. And again, if I wanted to write down the probability that B occurs, I notice that this is 4 out of my 6 possible outcomes. So I get a probability of 4/6 or 2/3. Throughout the examples we look at, we're going to have some underlying principles of probability that are going to be assumed to be true. Let me maybe choose blue here. So this first part here, for any event A, the probability of A must always lie between 0 and 1, and that's inclusively. So this is often a good way to find a mistake in your work. If you end up finding a probability that's ever negative or larger than 1, then you should know to go back and check your work. This second part here is maybe a strange notation, but this is saying if you add up the probability of all possible outcomes, that has to equal 1. So that just simply means, for instance, the probability of the sample space is going to be 1. And this is saying that something must occur each time you're running an experiment. So that second property is something that we're going to come back to, in particular when we're talking about series. So we see how that sum comes into play. So just for another example, suppose you have a 4-sided die, and instead of numerical values, the sides of this die are marked as A, B, C, and D. And in this case, we're going to roll this die twice. So the first thing we're asked to do here is to find the sample space. So the sample space, again, I'll use capital S to denote that, is saying that we need to collect all possible outcomes. Well, just as we said we could list the numerical value we see when we looked at a six-sided die, here I could let the capital letter represent the outcome. Because we're rolling it twice, then I would want to have some kind of pair of outcomes. So for instance, I know that the first roll could be A, and so could the second. And I could list the possible outcomes where the first roll is A. We should have 4 of those. Then I can list the possible outcomes where the first roll is B. Likewise, there should be 4 of those. The first outcome being C, there should be 4 of those. And then finally, let me put it down here, the first outcome being D. So we see that there are a total of 16 possible outcomes here. So I should say the other thing, unless stated in some way that the outcomes here are not equally likely, we can assume that each of these has a probability of 1/16 of occurring. So this second part of the example is asking us to actually compute some of these probabilities. So the probability that you roll 2 A's, that's going to be the probability that your outcome is AA, and that is one of our 16 possible outcomes. So that's just going to be the probability is 1/16. Now, if we say the probability that the first roll is A, notice that, again, having the sample space listed out can be useful here because I can go back and actually identify how many outcomes this corresponds to. So the first roll is A. You see there are 4 of my 16 possible outcomes. Let me just move that coloring. 4 out of 16, or 1/4. And I'll also point out another appropriate way to arrive at this answer is if you just completely disregard the second roll. This question is only asking about the first roll, and we know that A is one of the 4 possible choices. The next part here says that the probability that at least one roll is A. So at least one roll being A, what we want to think about is that I'm going to look at each outcome and basically circle it if it has at least one A. So this allows for the possibility of 2 A's. So first of all, notice that we're going to circle all outcomes that actually were included in part B, but there's more than that because we could have this outcome, this one, or this one. So I've circled all of the outcomes that so I'm going to underline this so this color code matches, that have at least one A, and there are 7 out of 16. And then finally, the last part here says the probability that you roll at least one A or at least one B. Notice that we've already looked at least one A. So I still want to include all of those. But now we also want to consider any outcomes we haven't circled yet that also have at least one B. So this one should be included, this one and this one, as well as these last 2. So now if you include all of the pink and the blue circles, we see that we have 12 out of 16 possibilities, or 3/4. So here we get an idea of how to use the sample space to kind of brute force calculate these probabilities. In the next video, we'll talk about some nice probability rules that can also help us more efficiently evaluate some of these probabilities.